What's up, everybody? We're back here on FreeCodeCamp.org doing a daily code challenge for September 25th, 2025. This one's called second largest. Given an array, return the second largest distinct number. It's a pretty short description, but it's pretty straightforward. Checking out the test cases here. Everything looks as expected. So I can think of two different ways to approach this, where I think really the only difference is coding a little bit more in order to make the function run faster. And we could talk a little bit about big O, time complexity. It's a way of measuring how fast your code can run as the data gets larger. In this case, the array gets larger. Will our code slow down because of that? And the difference with the two solutions I have in mind really comes down to sorting the array and then writing the code looking at the sorted version of the array. So I can start with that. We have sorted. We could use the toSorted method and just pass in how to sort it. Since it's numbers, we just look at the difference between our first and second parameter in our callback method here that we're passing to toSorted. So this essentially sorts the array. Now it's in ascending order, and we can look at that if, just to sanity check, console out sorted, and I will set this to be, how about let's choose this array that doesn't look like it's in order from our test cases, and I'll run that. And yeah, now we're in ascending order, 20, 31, 70, 67, 94, 139. So that puts it in order, and that makes it relatively easy to find what the second largest number is, because technically it'll be like the second to last value difference in the array. So we can kind of set our max to be what we can assume, since it's a sorted array, this is the last item in the array. Then as we iterate through the array, let's start at the end. And let's go until I is greater than or equal to 0. So we don't go out of bounds. And let's decrement I with each iteration. Now we can check, is this item greater than the max that I already know? So the item at the end of the array all the way to the right in the array is the highest value. So now let's step back a little bit and see, because we may have duplicates of that largest item, right? If there are, if the array is 139, like counting it from the right to the left, 139, 139, 139, and then 130, we have to iterate through those 139 duplicates to get to 130. We could get rid of duplicates with a set object, but we'll keep it like this, just because this isn't the final answer I think I'm going to go with. This is just kind of illustrating maybe an example of how you can look at the code you write to discover whether or not it's a faster solution compared to another. So I'm just thinking through this code I wrote. We have the sorted array. We get the last item, which we know is the highest value. Then we iterate backwards, starting from the end of the array, checking to see if the item we are iterating on, the max is greater than it, and then we return that because we've hit the second to the largest item in the array. I don't know what to return if we can't find a second to the largest, like if they're all duplicates. So I'm just returning 0. I don't know. We're not getting that case in our test cases, so I'm not going to worry about it. But that's something to wonder about this question. If you get this question like this in an interview, is like, well, what's my default value to return? Because you could also return like a -1. That's common in a lot of JavaScript stuff. If you can't find something, it's like return false, return -1, something like that. Either way, let's hold our breath, run the test. And that is a solution. But like I said, we're sorting the array here. And I believe the sort method that JavaScript uses, it probably is quicksort. And so that is n log n time complexity, which means that as n gets bigger, that is how the speed of this function scales. So if our array here is 10,000 items long, 1,000,000 items long, then we're looking at this taking, 10,000 times the logarithm of 10,000. And the graph of this, logarithms kind of, you have a big upswing and then it kind of levels out. So that's not terrible. It's not hideously slow. A hideously slow algorithm, if we like brute forced this and we had two for loops and we looked at every single item in the array for some reason, that would be n squared time complexity, which the graph of that is just a huge exponential upswing. And I mean, you could get information about time complexity and big O notation in another video. That's not really what this video is about, but just to mention it, if you think about the graph of what n squared would be, it's a huge exponential curve, whereas n log n is more of a However, if we don't sort the array, I think we can achieve an O of n time complexity. It's also known as linear time, and the graph of this just goes up at a diagonal rate. So as the array gets larger, the function gets slower at a very constant linear rate. So how do we do that? Let's reset the lesson. We could start over and think of this without sorting the array. If we don't sort the array, we will need a max variable, right? And the max, I guess we could start at 0, but I think we could also start at like a negative infinity. And if we get that returning from our function when we're trying to get this to work later, we know we screwed up with assigning maximum. We'll also need a max 2, right? Second to largest. So I could say second, right? Second maximum. I don't know. I'm bad at naming variables, but you get the idea. What we'll do is that we'll iterate through the array, not assuming it's sorted, and we will iterate through the entire array, which is where our time complexity of O of n comes from. We will perform a computer operation for every item in this array. And as we do that, we will save the largest value that we find, and we will compare, is this number in this iteration smaller than our maximum? And is it not our maximum? Then we can save that as our second largest. And then we will compare against second largest. So let's see what that looks like, because I don't even know. Set up our for loop as we do. And this is just a normal for loop, incrementing I, going from the left to the right, start to the finish of the array. With each iteration, we're going to check this item. If this is larger than our max, then we can store it as our max. But come to think of it, before we do that, we can take what our previous max was and store it in our second largest, right? So as we go through the array, we will pick up a maximum. At first, the first largest number we find, second becomes negative infinity. That's fine. And max gets that number value. And then we'll keep going through the array again. We'll find another item that is larger than our maximum, in which case what used to be our maximum becomes our second, because we can assure then that second is less than max. And then we assign this current item into our max variable. But I think we need something else. Else, if the array item on this iteration is greater than our second largest, and because we could have duplicates, if this isn't equal to our largest item. So I'm just going to call these, I'm going to rename this stuff just so it's easier to talk about. We have largest and we have second largest. Okay, that's super clear, I hope. And now I'll just replace these. Oh, geez. Okay, if our array item isn't larger than our largest item, but it is larger than our second largest item, we found something in the middle. We found something between them that this if statement wouldn't catch. And for that, we will put that item that we found, if it's not the same value as our largest, into this second largest variable. So thinking through this, starting from the beginning, we have 20. 20 becomes largest. Second largest just gets assigned negative infinity. That's fine. We get 139. 139 is larger than our largest. So we put second largest as 20 from our first pass, and largest becomes 139. Then 94. 94 isn't bigger than largest, 139. And then we get to this condition, is it larger than our second largest? It is. And it's not equal to 139, so second largest becomes 94. And it'll keep going, but inevitably we'll be returning 94, our second largest variable. And so this should generally run faster, I think. I'm new to thinking in big O notation, time complexity stuff. I'm getting back into data structures stuff, but I think a good way to interpret this is that this will run faster than if we had sorted the array first. It took a little bit more thinking because now we have to think about largest and second largest variables and make sure that everything gets assigned correctly. The method with sorting the array first had a much simpler set of logic in the loop, but I don't think this is too bad. And unless I made some little mistake here, hold your breath, I think we have our second solution. All right, so there we go. That is my answer here for our daily code challenge. Thanks very much for watching. I hope you have a wonderful day. Good luck on your coding journey, my friends, and I will talk at you later.